Alright guys, so Xavier is just preparing to weigh out the aluminium nitrate now. So as usual, just putting the beaker on the balance there and tearing it. Making sure it's stable before we start weighing. There we go. Now, holding the reagent just over the beaker so we don't have as much chance for spillage. Aiming for 8 grams of this salt. Getting close now. Marvelous. Waiting for that to stabilize. Looks good. So now we've got a mass to record for our first reagent. And we want to dissolve this in water while we prepare the ACAC solution. So just taking 50 mils of water and pouring it directly into the beaker that we've weighed into. Now that's already started to dissolve, and Xavier will just give that a little swirl, get it mixing in a bit better. Now while we wait for that to continue to dissolve, we'll move on to the next step, prep our next reagent. I'm just adding that directly into the aluminium solution. You can see we've got this layer forming on top, so we just need to give it a good stir. Mix the two phases of solvent in with each other and just ensure this reaction starts taking place. So I'll stir it for a few minutes. And we'll be back soon. Okay, now we've stirred our initial mixture for a little while and we're ready to start adding the ammonia solution. We're adding 30% ammonia. So we're adding a base here to deprotonate the ACAC ligand because it can't coordinate until it's deprotonated. Now, when we start to see a complex forming, we should see a pretty distinct color change and a dissipation of the two organic aqueous layers that we initially saw. So just adding that in bit by bit, and we'll periodically do pH tests to check that we're getting alkaline. Now Xavier's been adding the 30% ammonia solution for a little while. We can see the mixture has quite drastically changed. We've got like a white solid forming. So Xavier's going to test the pH of that. To do that, he'll take a piece of indicator paper and just drizzle a bit of solution on top. Not too much, we don't want to oversaturate it and only see solid on the front. So now we can compare this strip to our reference. You can see our pH is sitting at about 9. So we're alkaline and we're ready to move on to the next step. Alright guys, so we've got that reaction mixture cooling in ice now, and while we wait for that to chill, we're just going to have a quick demonstration on vacuum filtration by Xavier.
Alright, so when you're setting up your vacuum filter, a couple of things you've got to watch out for. These cooking funnels come in a variety of sizes, and so do the filter paper. So it's important to have a look and check whether your filter paper fits the funnel. This one, funnel's too small. Go a little bit bigger. Beautiful. Sits in there nicely. So the next thing is you want to make sure that your funnel in your flask is a nice fit. So pop it on there, press it down firmly, not too hard, so you get a nice seal around this rubber grommet. Next step, connect up your vacuum hose. You've got to be careful because these glass spigots are a little bit fragile, so make sure you just gently work it on the ends. Doesn't need to be on too far, it's under vacuum, so it'll seal itself up anyway. Alright, so once that's all set up, I'm just going to wet the filter paper with water. Use our squirter bottle. Not put too much on, you just want to soak the paper. Ease the vacuum pressure on until you see the filter paper sucking down onto the funnel. And we can turn that off. So now we've got a good seal from the filter paper to the funnel. We're ready to load our sample down the filter.
Now our solution's nice and cool. So Xavier's just gonna make sure of that. Pop it out. See how it looks. Check to see that it's cold to the touch, ice cool. Yep, nice and chilly, so we're ready to go. Now to load it on, Xavier's just gonna assist the transfer of the solution with the stirring rod there. That'll just help drag everything and direct it into the funnel piece. And now just dragging as much solid as we can really fit into the funnel. Taking it in steadily so we don't have any spillover. And now gently applying the vacuum. And see that starting to kick off a bit. Losing a bit of solution through there. You can see that we've got quite a good seal up the top because we're not getting any solid pulled through into the flask. And now we can see this is drying out quite substantially up the top. So we're going to rinse with water now. We already know our product's insoluble in water, so it's a good choice to help with the transfer. Xavier's just mixing that right up and adding that onto the funnel. Once again, just applying the vacuum. Takes hold pretty quickly. You can see that drying out. Now the vacuum's off again, just readying up for one more rinse of all of our reaction mixture into the funnel. Give it a quick swirl, get everything nice and disturbed so it's easy to transfer. And there we have the last of it popping in. Applying the vacuum one more time, letting that dry out. Now one more rinse with water. So we're just going to turn the vacuum off Rinse water all around the sample. Try to expose all of the sample to some water. And then once it's saturated, we'll turn the vacuum back on and pull it through. The sample's starting to look really sludgy. And now applying the vacuum one more time for that final rinse. And now we'll leave the vacuum on high for a little while just to air dry the sample before we pop it in the oven. All right, now our sample's been drying under vacuum for quite some time now. So Xavier's just sealed off the vacuum. We're preparing to collect that to dry it further in the oven. So you can see it's a crude sample is white with some yellow flecks. So further on in the manual, you can see where there's another purification step. So we're not expecting a pure product just yet. So we've got quite a lot of powder. We can see by the fact that it's all clumping together that it's still got a bit of moisture holding it together. It's not really a fine powder that's rolling over itself yet. Now we'll just get all of that onto the watch glass and we'll pop that into the oven shortly. Xavier's got our product in a watch glass. Got our oven cranking at 70. Just popping it up on the top shelf there. And we'll leave that for a while to dry. Alright guys, Xavier has taken the solution out of the oven, transferred into a beaker. Now we need to redissolve it in chloroform. So just adding it in a fairly good amount, about 50 ml initially. Now we need to mix that right up. We want to dissolve as much of our product as possible, but we know we have an aluminium hydroxide impurity. So we're expecting to have some solid still left by the time we finish mixing, and that's what we're going to be filtering off. So we're just going to keep mixing that up for a little while. And you can see Xavier's using a clean spatula to crush up any of the lumps of solid on the top there. Just try to squeeze out any of that product that's residing in there. Stirring it up a bit more, just trying to get it to a nice consistency before we start our filtration. Right, now we've got our mixture to quite a good consistency. You can see it's quite murky, so it's not fully dissolved, but we're not expecting it to be anyway. So we're about to see quite a lot of solid. So just gravity filtering this mixture directly into a round bottom flask. Solution down the bottom. Xavier's going to just take a bit more chloroform, mix it up in our beaker, and this will just aid with the transfer of the last part of the product. Just try to maximise our yield at every step. Mix up, just redissolve dissolving whatever product we have left in there and suspending any impurities. And we'll wait for that to filter.
Alright guys, as we're waiting for this filtration step to finish, it's almost done. I'll take you through the next step, which is using the rotary evaporator. So this instrument's really good for getting rid of excess solvent very quickly. There's 3 things that help you get rid of excess solvent quickly here. There's a heated water bath that heats up your reaction mixture. Your RBF goes on here, and you can also start it rotating, which increases the surface area, so it helps evaporate quicker. And you also have vacuum pressure, negative vacuum pressure, which will help vaporize your solvent. As the solvent travels up this section, it hits a condenser coil and it condenses, falls into this collection vessel here. So it should end up with pure solvent in here, your product sitting in the RBF. Before you start, just make sure that there's water running through the condenser coil, just here. Your vacuum control knob is back here, so once you put your reaction vessel on there, you can control the vacuum level, and just make sure that this valve is in the closed position when you start.
Sorry about that cut, guys. So Xavier's just applying the vacuum nice and steadily. So the goal here is just to decrease the pressure in the actual rotary evap vessel until we see this chloroform start to boil just a bit. We don't want it too fast. We want a nice steady evaporation from our round bottom flask. So we're not seeing any condensation just yet. Actually, just on the lines here, on the coolant lines, there's a bit of condensation. It's not enough to run down into the collection flask just yet. We can see this is starting to precipitate, just barely. So we'll keep running this for a little while, and we'll come back when we're getting close. Okay, so all of a sudden our product is super saturated. Just a critical amount of solvent has evaporated off. So there's quite a bit of condensation spread throughout this entire collection end. We're just going to continue to evaporate off what we can and increase the vacuum just to really try to dry off our product as much as possible, and then we'll collect it. Now we're ready to remove this off, so you can see vacuum. Xavier is just letting the pressure hit equilibrium with that valve there. So now it's safe to take this RBF off. You can see we've got this yellowish powder here, and just roll it around a bit. You can see it's dried off quite substantially by the way it rolls over itself like that. So the next part would be to collect this out of the round bottom flask and continue to dry it in a desiccator for another week before we weigh our final product.
Experiment 3.2 IR of aluminium complex. Alright guys, we're going to do some analysis of our aluminium complex using IR. So here we are in the instrument room. It's the IR machine and the PC that we're going to use to control it. We've got our product here with a spatula, a squirt bottle of ethanol and some Kim wipes. So the first step is to clean down the instrument. It should be clean after the last person that used it, but you're never 100% certain, so always good to clean it yourself. So a little spray of ethanol on the sample stage, and use a Kim wipe to wipe it off, and make sure that you wipe the anvil as well, just to make sure that you got all any product on there off. It's done. All right, so the next thing we're going to do is load up a little bit of our sample that we're going to be measuring. Now, you only need a small amount of sample when we're running the IR. Basically, all we got to do is cover this small square window here that you can see in the middle of the sample stage. So we really don't need a whole lot of sample at all. It's not a big issue if you use too much sample, but you're going to be losing your product. And depending on what it is, sometimes it takes a lot of time and effort to make your product, so you don't want to be wasting it by putting too much on the sample stage. So what we'll do is just get a little bit of our product here on a spatula tip, load it up onto the sample stage, and we're just going to move it to cover our square window in the middle. There you go. So just push it into the middle to cover our window. So you can see we don't really need that much at all. That's plenty. Now we bring the anvil down on top using this lever. Bring it all the way down, push it until it locks in. So now our sample's loaded, we can move over to the PC. So this software is pretty easy to use to take our measurement. Basically, we'll open up our parameters window, type in a file name, description, the directory that we're going to save the spectrum into, and we can set here the resolution of the scan, the number of scans it takes, and also the number of background scans, and the range that we scan across. So here we've got from 4,000 down to 400 wave numbers. So once we've set all that up, we'll take a quick sample scan. That just very quickly scans the sample on the stage and gives us a rough idea of the spectrum. You can see here. And we'll go down and we click Start Measurement down the bottom. And that'll go through and perform 8 scans and give us a reading of the average of the data. So it's going through and scanning now, and that'll give us our spectrum. So that's it, pretty quick way to analyze your sample. You can look up or refer to a IR data table to help you interpret these peaks that we've got here. And that'll tell you, inform you of the presence of certain atoms and bonds in your sample. And that's it, pretty straightforward, pretty simple. And you guys will be provided with a printout or an online version of this spectrum so that you can use that to fill out your results sheet at the end of the prac.